Hello everyone. Welcome to the seventh session under the Scikit-Learn series. Today we are going to discover the k nearest neighbors algorithm in Scikit-Learn. But before we get started with that, make sure you guys hit that subscribe button and bell icon so that you'll never miss any update from Intellipaat YouTube channel. First of all, let me take you guys through the agenda that I have built for this particular session. We'll begin this session by building a basic intuition for KNN algorithm. Then we'll discuss how exactly this k nearest neighbors algorithm works. And then finally, we'll delve into the hands-on demo part where we will generate the working k nearest neighbors model. I hope all of you guys are clear with the agenda for this session. So, without further ado, let's get started with the first topic of this session, that is building a basic intuition for KNN algorithm. From the learning till moment, we could say that machine learning models make predictions by learning from the past data available. We pass input data including both features and labels to our machine learning model. Then our model learns from those provided input values. It sort of builds an intuition over the data that has been provided, and later it transforms newly provided data samples into the possible and feasible outputs. Now, by this time, I hope all of us are pretty clear with this notion. Let's consider one real life example of classification. The girl shown in picture asks her mum if the animal passing them by is a lion. Well, her mum responds no. I mean, how the hell lion will end up in the backyards of kindergarten, right? She further says to her daughter that you can differentiate between a cat and lion based on their characteristics. Now, we know that cats do have small and sharp claws. Their height averages between 23 to 25 centimeters, which means they are quite smaller. The ears of cats are very small, as well as these small creatures always meow and purr. Also, they are very friendly and you can pet them. Whereas lions have strong, large, and sharp claws. Their height averages between 90 to 110 centimeter, which means that they are comparatively big. They have long ears and they roar. Furthermore, these creatures are not so friendly and hence they are categorized as wild animals. Now, just by using two characteristics such as the respective heights and the lengths of ears, we could easily classify cats and lions, alright? Now, after saying all this, the mother of kid asks her, now you tell me the animal that is passing us by is cat or lion. Now, the kid visualizes the characteristics such as height and length of ears. By now, the kid knows that the cat has smaller ears and less height, and he can see that the characteristics of passing by animal are more like cats and it seems to belong to a cat cluster. Hence, it must be a cat. And this is exactly what a KNN algorithm process tries to achieve with more sophisticated and reasoning procedures. Basically, this algorithm takes in feature similarity into account, hence, it is commonly used to carry out the classification. So, we have our testing input value, that is the image of black cat. We pass it to the trained KNN classifier and it predicts that the given animal belongs to category of cats. Now, let me formalize the KNN in more technical terms. Guys, KNN or K nearest neighbors algorithm is one of the simplest supervised machine learning algorithm mostly used for classification. So, if we want to know if the given animal is dog or not, if it is cat or not, then KNN is one of the feasible solutions. It basically classifies a data point based on how its neighbors are classified. It stores all available cases that are being provided while training and then classifies new data based on similarity measure. Similarity measure is the important feature of this whole KNN thing. Alright, guys. Now, for example, consider cat versus lion classification again. So, once the new data sample is provided, the algorithm will try to match it with the characteristics of closer neighbors. Well, if you ask how, guys, the k in KNN stands as a parameter that refers to the number of nearest neighbors to include in majority of the voting process. So, if we add a new animal that is a dog or cat, we want to know what the neighbors are. In this case, let us put k is equal to 4. We'll talk more about k in a while, but for now consider that k value is equal to 4. Guys, one more thing I want you to take out of this session is that in KNN the unknown point is classified by taking the majority of votes from these k nearest neighbors. So in our case, we'll find out the 4 nearest neighbors, we'll see to which category the majority of them belong to, and then we'll put that unique new observation into the category that the majority of our neighbors belong to. So in this case, you could clearly see that all 4 objects in our cluster are cats. Hence, the new item, that is the black image of cat, should belong to cat category itself. Alright. But how do we exactly choose this k value? How do we know k equals to 4? I mean, how do we decide what value this k takes up? Guys, till the time we have understood that KNN algorithm is totally based on feature similarity, and one of the important aspects of it is choosing the right value for parameter k. The process of choosing this value is termed as parameter tuning, and it is a very important aspect that is going to determine the accuracy of our model. Let's say we have k is equal to 5 and we want to determine the category of this black sample. We have two different categories, a red triangle and a blue box. Now we'll see which category maximum number of neighbors belong to, and we will classify that sample to this majorly voted category. In this case, it will be a red triangle since we do have three red triangles and two blue boxes. So we have majority vote for triangle. Now let's say we have k is equal to 7. In this case, what category does our data sample will belong? I think we have opposite samples in number for this particular case. So this sample will belong to the category of blue boxes. Alright. So you can notice with just increase in the value of k, our results take a big turn. And that leads us to the question, how exactly are we supposed to choose this value of k? Across the machine learning algorithms, the most haunting part is parameter tuning. And I know by now you must be scratching your heads. Well, let me put forward a way of choosing k. So we want to pick value of k such that bias will be not too high in one direction or the other way around. If you pick the value of k that is too less, the bias will be high. I mean, our model will make very vague predictions, or what we call in technical terms a skewed prediction. And if your k is too big, it will produce processing issues because you'll have to compute distance between many points, and eventually that will lead to processing issues. So what we generally do is we either choose k value by hit and trial, or what we do is we take the square root of overall data samples that we have in our data. Also, if you have an even number of samples, you should make your k value odd. If you keep it even, there is a possibility that you won't be able to avoid confusion between two classes of data. These two important rules, that is square root and odd value, are the only parameters that we use while choosing k value, and believe me that they just work fine. Now the next thing I want to talk about is when should we use KNN. Well, guys, we can use KNN when the data is properly labeled. For example, the dataset that we discussed in the beginning. Either the animal will be cat or it will be a lion. Then the second requirement for KNN to work would be data should be noise free. Now look at this data snapshot given here and check the labels. You could see that there is a lot of noise in this data sample. The labels are somewhere in textual format, somewhere they are in numeric format, and somewhere they don't even make sense. So these sorts of data sets cannot be processed with the KNN algorithm. Another thing to keep in mind is that KNN cannot be used for huge datasets. The reason behind that is KNN is a very lazy learner. It does not learn the classifier from provided training data samples. Also, since it is a lazy learner, the computation for generalization of the predictions is deferred until classification. Although this method increases the cost of computation compared to other algorithms, KNN is still the better choice for applications where predictions are not requested frequently, but where accuracy is the most important part. Now, let's talk about how this KNN algorithm works. Consider the obese and non-obese type of data that we discussed in the logistic regression session. We have the feature data about the weight and height of people and label data that conveys if a person belongs to obese category or non-obese category. Now let's call this data as training data. And we also have been given a testing sample. And our challenge here is to predict whether given sample belongs to the obese category or non-obese category. To solve this problem with KNN algorithm, first of all, we'll need to figure out the closest neighbors to the data point. And to do that, we'll have to calculate the Euclidean distance between the test point and each other point in training sample. Now, what exactly is this Euclidean distance? Well, the Euclidean distance, according to its formula, is nothing but the distance between 2 points in plane. Now, suppose I have 2 points, one with coordinates x1, y1, and other one with coordinates x2, y2. Then the Euclidean distance will given by square root of x2 minus x1 square plus y2 minus y1 square. Now let's make use of this formula and contemplate the Euclidean distance between this rate testing point and other training points. Let me show you one such computation as an example. So suppose, let's say I want to compute the Euclidean distance between these 2 points connected with a dotted red line. The coordinates for the red test observation are 57, 170, and for the blue training observation they are 51, 167. Now, if I put these values in the Euclidean equation, then I'll get the resultant distance value as 6.7. Similarly, like this, we have already computed the other Euclidean distance values for all other points in our training sample. You can verify them by putting previous values in the equation. But we are not going to do that to save us some time, alright? Now, let's say we set k value as 3. That means out of all these values, we need 3 nearest neighbors. So, by traversing through this list, you could easily find out that these are the data observations which are closer to our given observation. Hence, according to the principle which KNN works, the test sample will belong to the label which has higher votes and which is none other than obese label. Alright. Now, I hope all of you guys understand how K nearest neighbor works. Moving forward, we'll visit a Colab notebook and implement one such KNN model with the help of Scikit-Learn library. Alright guys, to get started with this KNN implementation demo, let us load few important dependencies that we will be using throughout the coding exploration. The first one will be import numpy as np. Then we'll import pandas library. Then we'll import matplotlib library for visualization purpose. We'll also import the seaborn library. Then we are also going to load the toy dataset framework from scikit-learn. And for that purpose, command we have is from sklearn import datasets. And the dataset that we are going to use for this particular session is going to be a wine dataset. So let me load that to our notebook with the help of load underscore wine function as well. So I'll say data is equal to datasets dot load underscore wine, and we'll set as frame equal to true. Now let me run this block. Now let's see how our data looks. So here you can see that we have 178 rows in our dataset and 14 columns. And we have a target name such as class 0, class 1 and class 2. And we have 13 attributes and their names are also have been given here as well. Alright. Now this visualization of dataset is not much clear. So what we'll do is we'll store it into a data frame and we will visualize it laterwards. But to do that, first of all, let me split our data into X and Y parameters, that is the feature data and target data. Now X will store the date feature part and Y will store the target part. And we'll also get more information on target classes that we have in our dataset. We saw it in info part as well, but let me get those names printed as well. So names is equal to data dot target underscore name, and I'll print these names. Alright, so here you can see that we have class 0, class 1 and class 2. Now, the next thing we want to do is visualize the distribution of our dataset. And to do that, we are going to use pair plot functionality in Seaborn library. Basically, it will provide us with scatter plot of each feature against every other feature in our dataset. And visualizing it will give us an idea about how these features are affecting the classification of our data sample. Alright. But before we do that, we'll store our dataset in a data frame. Now, first of all, I'll create the data frame. Then I'll store the feature data inside it, and I'll set columns is equal to data dot feature underscore name. Next, I'll insert the label data, and I'm gonna name label as wine class. So df wine class is equal to data dot target. For visualization purpose, we don't want to deal with numbers. So we'll replace the 0, 1, 2 with wine class titles such as class 0, class 1 and class 2. And to do that, I'll write command df wine class will replace values such as 0, comma 1, comma 2, two values, class underscore 0, then class underscore 1, and then class underscore 2. Okay, I am missing the equal to mark here. Now let's rerun this block. Alright, let me show you how our data frame looks now. So I'll print the data frame here. Alright, from this snapshot of our data frame, you can see that we have overall 13 features and one label, that is the wine class. So basically, these 13 features are describing the composition of a wine, and based on that, the wine is classified into three further different categories, that is class 0, class 1, and class 2. Alright, now let me help you visualize this distribution of our data in more sophisticated way. For that, we are going to use one of the best EDA functionality, that is pair plot, available in Seaborn library. And to do that, I'll write the command sns dot pair plot. I'll pass the data to it, that is our data frame. Then I'll set the hue to wine class, and will also set palette to set to. Now let me run this block. Now after we run this block successfully, you can see multiple graphs over here, right? And from these graphs, one thing that is significantly visible is the dataset seems linearly difficult to separate. But all the data samples seem to find cluster with other elements that belong to the same category. Hence, I think KNN will be the better fit for the classification purpose. Now, the next thing that we are going to do is visualize if we do have any null values for imputation purpose in this dataset. The command to do that is df dot isNull dot sum. Here you can see that we have no null values in our dataset. So we don't have to worry about imputation. So the next thing we'll do is we'll segregate our data into training and testing samples. Now, for that purpose, we are going to require the train test split functionality, which is part of model underscore selection module in sklearn. And we'll load it first. Then from sklearn dot model underscore selection import train underscore test underscore split, and we'll segregate our data into train and test samples. that is x train, comma x underscore test, comma y underscore train, comma y underscore test, and train underscore test underscore split the input vector, that is x, and the target vector y. Will set the test size as 30% and will also set random state to 1. Now, the next step will be creating the k neighbor classifier or the instance of KNN module. And for that purpose, we'll load the KNN classifier from sklearn dot neighbors import k neighbor classifier. All right. And one more thing we talked in the beginning is that what we are going to do is we are going to take the square root of total length of our data sample, and then we'll set that value as our k value. And for that purpose, let me import the math library to contemplate that square root value. So math dot square root of len y underscore test. Okay, y should be small. All right. The value that we are getting is 7.34. So we'll round it up to 7. All right. So we'll create the KNN classifier. So KNN is equal to k neighbors classifier with neighbors equal to 7. Now we'll fit our training data to this model x underscore train, comma y underscore train, and we'll store our predictions inside the pred metric and we'll pass the x test to predict function. All right. Now let me run this block. So the next thing will be visualizing the accuracy, and for that purpose we are going to require the metrics framework available in Scikit-Learn, and from this metrics we are going to invoke accuracy underscore score function, and we are going to pass the testing sample as well as the made predictions. And here you can see that we are getting 64% accuracy. So this accuracy is pretty less, and the reason behind that is our dataset has varying values. All right. Now to resolve this problem, what we can do is we can scale our dataset with the help of standard scaler. So let me do that quickly and see if we are getting better results or not. So I'll get a new block here. I'll write from sklearn dot pre-processing import standard scaler, and I'll create the object of the standard scaler, and I'll fit our training data and testing data to it. So x underscore train will be fit to sc dot fit underscore transform, and similarly we'll apply it to the testing features as well. Now let's create the another instance of our KNN classifier. So KNN 1 is equal to k neighbors classifier, and number of neighbors will be equal to 7, and the metric that we'll be using is again the Euclidean. Now let's fit our data to this newly created instance of our classifier. So KNN1 dot fit x underscore train comma y underscore train, and we'll create new predictions. All right, I'll have to set it to KNN1. Now this should be fine. Now let's calculate the accuracy score. Metrics dot accuracy underscore score y underscore test comma pred 2, and from here you can see that we are getting 98% of accuracy. The only reason we were getting less accuracy at the first attempt was because our dataset had high variance and the values were varying from each other. But once we scale them down to the better scale, our model is producing better results, that is 98% accuracy, which is a very great accuracy in terms of machine learning. All right. Now, I hope this implementation part is clear to all of you guys out there. That's all we have for this particular session. I thank you all for being here till the end of the session. I hope the session was informative and enthralling. If you have liked this video, a thumbs up would be much appreciated. Also, if you have any concerns about said concept, then please put them in the comment box below. Our 24 by 7 team of experts would be obliged to resolve all of them for you guys. Also, make sure you are subscribed to the Intellipaat YouTube channel so that you never miss any update from our team.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.